Hello, welcome back. The series of lectures we are into, sorry, friction. Uh, we were looking at some of the cases of the static friction, then the limiting friction, and then we also looked at the variable coefficient of friction. The other day, I think I spoke about that. Sometimes you may come across like that also. They may give, and then I have shown you fixed incline and how do you get those uh, values of acceleration, etc. The time taken for the body to slide down, the velocity with which it reaches, and if it is n times the other one, etc. There could be some problems of that nature. For example, you have, supposing this is beta, half this is smooth, and this is rough. And the body just comes to rest once it reaches here, once released. I hope you're able to get this. The coefficient of friction here is mu. And now, by the time this body enters here, v square is equal to 0 square plus 2a s. This is the velocity with which body enters here. That becomes the initial velocity here. Therefore, this is this. Okay. Now this u is equal to this in the rough terrain. And what is the acceleration if mu is constant, of course? So how do you get the say the retardation there? The body comes to rest, he said. Therefore, I'll put it here for you. This is mg, sorry, beta, this is beta. Mg sine beta, and this is fk. And it is a retarding. That means what? This is more and this is less. So what do you do? Fk minus mg sine beta is equal to ma. And this is mu n. N is, because this is a fixed inclined surface. So A is equal to now this is against what we were getting, you remember, G into sine beta minus mu cos beta, where then it was accelerating, and that angle is, in that case, angle more than angle of repose, and here beta is less than angle of repose. Then if you leave the body there, it will not move. But the body is pushed, therefore we are forced to take like this. So this is acceleration in this direction. Or A is equal to minus G into mu cos beta minus sine beta. Okay? Now, right. So, v square, 0 square, minus u square, because velocity is 0 here, the velocity is here, minus 2a, yes, minus gets cancelled, g to as. As means L by 2, because this is L by 2, 2 gets cancelled, LG gets cancelled. Then what are you getting? Sin beta is or mu is equal to 2 sin beta by cos beta. They may ask you questions of this nature. Whichever way they ask, you can do that. Okay? Okay, fine. That's how the questions could be. I think whatever it is does it accelerate or does it retard? Is something that you have to see and then work on that. Now, with this background, we enter another arena of friction. This is generally very confusing to people I saw. Very confusing. What exactly is that? Say, here are bodies. This is mu1, this is mu2, and one case is you are applying a force F. The other case, one, two, two different problems. One I'm applying force on the lower body, here applying force on the upper body. What are the various scenarios? Everything we are going to work out. And this is important because how to attack problems of this nature. I told you, whenever you go to friction, friction always has a relative tendency, relative motion, relative acceleration, relative velocity, etc. Okay? Now, if you want to get relative acceleration, then you are supposed to consider pseudo force. It becomes easy, not that you should consider, but it becomes very easy for you to handle. Therefore, first I'll start with this model. Well, it takes a long time, and I want you to follow very carefully because once you understand this model, I would give you a certificate that yes, friction, you have no issue at all. So people who are going through this are expected to work this out independently at least 4 to 5 times. And you must be absolutely familiar with this. Then only your confidence levels will go high, and don't simply say, okay, I have understood, and you keep quiet, you will never understand. And it's not that easily understood, let me tell you, okay? So now what shall we do here? There are various questions they'll ask. What is the minimum force for this body to system to move? And when does this body fall off, etc., etc. First of all, let me take a force which is much more, and the whole system is accelerating. Imagine for a while, if the system is accelerating, what will happen to this body? For example, I will tell you, maybe this will be a better proposition. I am giving you, this is M1, M2, smooth, F, L. What's going to happen? Let us just to visualize that. Now, here is the body, I'll tell you. It all depends on how you are looking at it. Now look, Here is the lower surface. Okay, I have placed the body here. Now I say there's no friction between the two. Follow me carefully. What are you pulling? Lower body. See, you see, if you see that I am putting the pen here, that is M2, and lower body will go and then this will fall out. I want you to see. If I show it here, it appears that this is moving with respect to this backwards. Are you able to follow? In reality, this is not moving at all. The lower body is moving because there is no grip between the two, which we call as smoothness, and this body will fall off eventually at the same spot. What time does the body fall off? This is the question. Now, what do we do for that? I'll tell you. If you draw FBD for this is F and 2 and 1, no friction anywhere. This is M1, F is equal to M1A. Or A is equal to F by M1. Now, lower body, upper body, M2. No force is acting because this is, of course, here you have M1G, this is M2G, this is M2, no force. But if this is accelerating with A, relatively if I want to consider, I take pseudo force to be like this. And therefore, the relative acceleration is in this direction. Now look, I'm taking the most simple of all the cases and then working on. If this is AR, then this is the only force that is acting. So M2A is equal to M2 into AR, or AR is equal to A is equal to F by M1. What is the initial relative velocity? U2 minus U1, 0. I hope you are understanding this, right? U2 minus U1 is equal to 0. And what is AR? That is obviously A2 minus A1 is equal to F by M. And what is the relative displacement? With respect to this, how much is this covering L? In reality, M2 doesn't move at all. It will fall there only. So the relative acceleration is L. Now you can see, if you have UAS, what time does it fall? If I ask you, yes, S is equal to UT plus half AT square. Half A T square. Therefore, T is equal to 2L M1 by F under root. Now, in this time that body will fall. That's what they'll ask. And what is the relative velocity, they may ask? VR. V square is equal to U square plus 2AS. 0 square plus 2AS. So VR is equal to 2FL by M1. In reality, velocity of the upper body 0, lower body is this. So relatively upper body is minus of this because I took in the opposite direction. That is for a smooth surface. Now this is what we are going to do in almost all the future problems. So I want you to be familiar with what I'm going to do. Every time things are given, you're supposed to write like this and then use your kinematic relations wherever there is no integration involved. Okay? Now, instead of that smooth case, first case I took smooth, now this is case number 2. In this, what are we going to do? In this, same question. First of all, what time it takes for it to fall off? Presuming the whole system is accelerating and the body is moving backwards relative to this. In reality, what will happen? I'll show you. After some time, so this is about to fall. If you see, this is the actual displacement of the lower body, isn't it? This edge to that edge. I hope that's clear. And this is the, of course, with respect to the ground only. And you know that this is L. So how do you write S2 plus L is equal to S1? And this is what I'm saying as relative displacement for the body to fall off. I hope this is clear to you now. In this case, it has moved because of friction. In the previous case, this body will remain here, whereas this will move off. Okay? So it's all visualization in the case of friction. Fine. So whenever I want to know when the body actually moves like this. So they may ask, what is the actual, let us say the whole time taken for this is t. They may ask, what is S1? Half A1 t square. Whatever is A1. What is S2? If you know its acceleration with respect to the ground, initial velocity is 0, so you can put, based on that, if it has velocity you put, otherwise you don't put. So you will say half at into t square. Okay? But what am I going to do? First of all, I'll draw FBD. I'm taking all the bodies are slipping. This is slipping on this is slipping. This is the most complicated version of a two-body system. When force is applied on the lower body, I'm going to discuss this at great length. I want every one of you to follow carefully. Okay. Now, let us draw FBD of the first body. Okay. So, first body, FBD. This is F. Now, this will, see how am I putting it here? F1, because it is slipping, you will get only kinetic friction. And this is also slipping. Now you see how to get the direction of frictional force by 2 on 1. If 2 were not to be there, how this body would move? Of course, in this direction with more acceleration. If I'm placing it, obviously, if the same force you apply, it will not accelerate that much. That means what? The friction between these two is opposing the lower body. Hope this point is clear. I'll explain in another way. If I draw FBD, what are all the forces acting on this body if I take? Why should this body move from here till here? Because of friction. Now you recall, I was trying to make a temple for friction, because you want to keep it here. and you want to take it, well, this doesn't move. The pillion sitting on the back side of a scooter or scooty or whatever, and if there is no friction between him and the seat, and this driver will drive and then go off, that fellow will remain where he is. So, because of friction, this is moving forward. So, frictional force by 1 on 2 is forward. Therefore, by 2 on 1 is backward. I hope you got this. Now, drawing this diagram is the most crucial thing. How to get the direction of frictional force is cool. Two things I have explained it to you. When I am placing this body here, if I remove this, if I use 100 newtons, I will get a certain acceleration. If I am placing this and use only 100 newtons, then how much acceleration am I going to get? In the previous case, if it was to be 10, now it will be only 8 or 7. So this is impeding the motion. The upper body is impeding the motion. So when I am placing it here, something is opposing, and obviously that is interactive force. Therefore, F2K is opposing. Hope you got this. And this is N2. This is N1. Don't try to draw N2G there. That is force by gravity onto. I am not interested when I am drawing for 1. Force by gravity on 1, force by surface on 1, force by 2 on 1. I took all that. And I am presuming that it is going with the acceleration. Even how do you write? F minus F1K minus F2K. This is a very important relation. I may erase that at any stage. So I'm writing it here. This is equation number 1. What about this? N2 plus M1G is equal to N1. N2, this is 2. So 2 equations I got from this. I hope this is clear to you. Now I am erasing this FBD of the first one and going by this, gravity acting on this, first body on second body, and if this is going with A1, the pseudo force will be M2A1. Right? Now the more you apply the force there, the more will be the pseudo force. So eventually this will exceed F2K and the body tends to move backwards relative to the lower body. I hope you understand this point. So your relative acceleration is like this. Right? How do you write? M2 A1 minus F2K is M2AR and N2 is equal to M2G. This is 3, this is 4. I hope you have got everything clear as far as this diagram is concerned. Okay. Now, let us solve this one by one. F1K, how do you write? Mu1 N1 F2 mu2 N2 M1A1. So I have written N1. What is N2? M2G. So what is N1? M2G plus M1G. So N1 is this. I am writing F1 minus M1 plus M2 into G. N2 is M2G. This is M1, A1. First of all, I'll try to find out AR. How do I get AR from this? If I write M2A1 minus mu2, M2 is M2G, M2AR. AR is equal to A1 minus mu2G. A1 you can substitute from all this. How? F by M1 minus mu1 by M1 minus mu2 M2G by M1. Alright. Then there is a term here minus all the 1, 2, 3. 1, 2, 3 I took from here, second term here. So here what I do, multiply and divide with M1, it doesn't make any difference. So denominator is common, and you can see here F minus mu2 into whole divided by M1, or F minus M1 plus M2 this is, this is a very, very important result. What did I do? Let me, I think, come back and then try to explain this thing to you yet again. I have placed a small body over a larger elongated body, and I am applying force on the lower body. Friction is present everywhere. The surface friction is present. In between the bodies, friction is present. I am trying to move that lower body. Presuming that all bodies are slipping, then everywhere frictional force is bound to be kinetic. So if that is the case, at what time does the body fall off the lower body? I have to first get the relative acceleration. And relative acceleration, how to get it, I have shown you. The lower body FBD I drew, I got two equations. Upper body FD with the pseudo force. Every time you work in friction, better to use pseudo force technique. The pseudo force technique, I got these two equations. And then between these four, I have tried to work out what is AR. Once you get AR, the other part which I told you, that what is the initial relative velocity? Initial relative velocity between the bodies 0. Relative displacement L. Okay? And AR is known. Right? So what is T? What is S is equal to UT plus half AT square. L is equal to half T square AR. AR means all this. So T you can find out from this. In this time, this body will come off. I hope this is clear to you, right? And as I said, what is the relative velocity at the instant it falls off? V square is equal to U square plus 2AS. 2L 2S A. A means all this. That's how you get it. Anything they ask, you can find out. Now, so this is the time in which it has fallen. And what is the time? 2Lm1 by. Okay. Okay. This is the time in which. Now, what is the actual displacement of the rho n body? Half A1 T square. T square, you substitute all this. A1, you have it with you. Where is A1? A1 is this. You have to find out A1. How do you get A1? From this equation. So how do you get that? I'll write mu1 m1 plus m2 into g minus mu2 m2g